afternoon, everyone. We are delighted to welcome you all to the IDEATHON, a special event of this first international conference on advances in water resources being hosted here at MANIT Bhopal. It's an honor to see so many bright minds gathered over here to share the goal of innovation and sustainable water future. The IDEATHON I want to describe a bit to all of you. It is more than just idea sharing or creativity. It's about collaboration and vision. It is aligned with the mission of AWaRe 2025, and it aims to spark practical, scalable, and original ideas to address challenges in water conservation, management, accessibility, and technological integration. As we face increasing pressures on our water resources, your ideas can contribute meaningfully to future policies, research, and innovation pathways. So, with this, I would like to welcome our panelists for today. Uh, please give the introduction of the panelists.
Now, I would like to invite our core panelist, Mr. Adit Sarma, CWC. Please come on the stage. Professor Rajiv K. Bhattacharya, IIT Guwahati. Professor N.V. Uma Mahesh, NIT Warangal. Professor Rajiv Maiti, IIT Kharagpur. Dr. Ravi Galkate, NIH. Dr. Professor M.K. Goyal, IIT Indore. Professor S.N. Query, IIT Madras.
The theme of Ideathon is innovating for water resilience, smart, sustainable, scalable. This theme invites you to explore ideas at the intersection of technology, policy, community engagement, and environment sustainability. In this Ideathon, we'll be sharing the problems regarding some of the environmental issues, and we expect that our expert mentors will put forward their original ideas to solve those problems, and definitely we are going to benefit from all the recommendations from this Ideathon. So without any further delay, let us start this event. There are various sections or various themes of the discussion. First, we can take groundwater management and regulation.
Participants, please come. Please sit in front of the.
Uh, we have got several problems from our participants. One of the problem is that we are using groundwater potential zones. We are working to identify groundwater potential zones using MCDN machine learning. We all have heard about it. So can any of you can share ideas or thoughts like how we can for effective groundwater modeling, and how can academia and government work together to overcome the data reliability gap? If anyone would like to share their thoughts on this, like integration of academia and government. Whoever is interested, we can whoever is interested. Just see.
Hello. No, no. I think in case of yeah, no, and I think I will speak a little bit overall about the groundwater problem. So suppose for modeling groundwater, okay, so groundwater or assessing groundwater. So the problem what we face is the data problem. That is the primary problem that we do not have the information about the aquifer, or basically this information is not readily available, or in most of the I think most of the areas we do not have any information. I think now there is a mission by government of India and NGRI. Actually, they are they are actually they've given some project for groundwater mapping. So what they are doing basically, so I think right now what they have started. So anyway, so I will not be able to tell details about the project, but I am aware about the initiative. So under that initiative, they have taken Madhya Pradesh, Rajasthan, or some areas actually in the first phase. So they will do the hydrogeological mapping of the area. So the idea is that suppose maybe within next 10 years or 15 years, so we'll have the hydrogeological map of entire India, basically just like in if you go to US or other country, you have already these informations are there. So this information will also be readily available. But right now under this project, they have started. So far, I remember it is in Rajasthan and Madhya Pradesh. So once we have this information, certainly the modeling point of view, so we have the software, or we have the method basically, or we have the modeling capability, so we can model accurately. But only the problem here is the that aquifer information. So this is basically one of the major issues related to groundwater modeling. So once this project is completed, probably, but right now I think you will get really high resolution data of this particular area. So this information will be able to give by NGRI Hyderabad because they are working on this particular project. So once this is available, probably we can have better understanding or better modeling capability of or groundwater management issues. Yeah. Thank you.
Thank
Unfortunately, because most of data is becoming open, the open source available, and then it's not getting data is not difficult. How we use the data enough actually to project what's happening is more important. That's what we need to focus upon. But basically, the major topic that's going on, I think we're talking about the stormwater management model. But I'll not talk about the modeling part here. But let me, I think morning also I was talking about the upfloods, which is one of the major issues that we are facing in many of the cities, major cities. So I just talked about the experience that we had in Hyderabad. Uh, so this experience, I think, is something which we need to learn from this and then evolve some policy, because
say most of our cities are becoming completely unsustainable. In the sense because the cities are growing rapidly. Like I just take an example of Hyderabad. Hyderabad earlier, maybe in 70s, the water supply was from two reservoirs constructed on River Musi and its tributary that was sufficient to meet the requirement of water. And then later they constructed another reservoir on near Singur on river, Godavari, tributary Godavari. And then now we are thinking of importing water from Krishna Basin. So means how long can we sustain like this? We are importing large amount of water because there is growing demand. At the same time, there is a lot of usage of water. So I think we are not learning lessons from these issues. So how do we make our cities sustainable? So I think if we look into this problem as a whole, I think the stormwater also is a part of that. The management of stormwater, management of wastewater, and then water supply in a city. I think this is all integrated together. They are together. We have to look at it holistically and then see how to manage these resources and so that we can make our city more sustainable. I think this is what we need to look at. Whatever we have learned, because cities like Hyderabad or Bangalore, these are already damage is caused, and then we are only looking for how to tackle that. But we're not looking at the two-tier cities or three-tier cities which are growing. Uh, so I think when we start developing the cities, when we start urbanizing the cities, we need to have a policy. When a new locality or a new, say, suburban area is coming up near a city, we need to have some kind of policy on how do we manage the water sources, all the three waters that we have, the water supply, wastewater, and then the, say, stormwater. I think unless we have a policy, we talk about smart cities today. I think, but the focus given for various system or water management in smart city is very, very limited. Unless you have proper management of water, I think no city can become smart. So it's not just the cleanliness or having IT sector and all those things. IT services is not that doesn't make a city smart. The living condition of people has to be good, and that can happen only when we start managing water. So I think it is right time for us to sit together, both academicians as well as the industry people, the field people, to come out with some kind of a policy so that at least the lessons that we have learned from the cities like Hyderabad, Bangalore, Delhi, etc., we see that this kind of mistakes that we have done there in developing the city will not happen, and we have a better management practices in this new cities to come up. That's what I would like to.
Myself, Dr. Ravi Galkate. I am from NIH. Actually, we are talking about uh, how the data requirements, what are the data requirements for groundwater modeling, and how we can improve upon. Actually, I am not a groundwater person, but still, I would like to say that Madhya Pradesh recently has, I think 1 month back, there was a this thing report that CGW is going to increase their observation sites in the Madhya Pradesh. I think it is going to be doubled. You are from CGW? Yeah. So that is one of the benefit that we can have more data, almost double data. At I think presently we have 1100 locations, observation point, 1400. It is going to be 2500, definitely. So definitely this increasing number of gauging sites, observation sites of groundwater data will definitely improve the data availability, and it will definitely help to in the modeling purposes and decision making from groundwater management matter. As far as stormwater management model, I think Chennai, IIT Chennai is working on that, as you have told. Our regional center Belgaum, it has already worked in some part of Chennai, and they have collected, I think, 15 minutes interval data also, and using that they have run that model, and they have some observations regarding that. And one more thing I want to point out here is that, sir, yesterday we had a very good discussion. Professor Rangaraju has given us this, he has raised this issue of urban flooding. Actually, these two things are very important to be seen. Like at the same time, we are having urban flooding, water is going out of the city, and we can see the groundwater levels in the cities are declining. So it is because of the pavements, constructions, which are taking place in the cities. So the recharge area which we had earlier is reducing. So definitely our recharge area is reducing, means groundwater recharge is going to be decreasing in that areas. And at the same time, huge amount of water is going out of the city or out of our area of our interest. So it is causing flooding. So yesterday, sir has given number of this thing measures which will be helpful to control this situation. Like in the first, he gave that rainwater harvesting, then diversions, then tunnel, then number of measures he has suggested, and each measure is very much important. And sir has rightly said, India today do not have financial problem. They can go for the tunnel, but I think it is a very big task, and how it will take place, it will take time. But in my opinion, rainwater harvesting is very easy method. Individual can adopt that method, and definitely individual can contribute to that problem, to reducing the, because rainwater harvesting, we the problem which we are having, reducing recharge area. So what we are doing, we are collecting, harvesting water from our rooftop and putting it into ground. And at the same time, the amount of water which is being recharged is definitely, if we do it on a larger scale, it can definitely reduce the urban flooding. So at the same time, rainwater harvesting is a major, I think is a can prove to be a good tool, or say good method, which can be adopted easily by the peoples of that particular region. If you see in a city, I think whatever the city area is there, 10 to 12% or 30% maybe the rooftop area on an average. I have not calculated, or I have not, but if you can assume that quantity can be reduced from reaching, and for from which is causing the flood in the cities. And it is at the same time we are recharging the groundwater, so it can be beneficial to address both issues. I think at the same time, urban flooding and this thing. And one more thing is that we lack awareness uh, of the rainwater harvesting. Even many of us sitting here may not be knowing how to do rainwater harvesting in their home. Because if you study it, if you see the Google and YouTube's, you can do it. And I think that component, considering that component of rainwater harvesting in the modeling, can definitely help those people, those who are working in the groundwater modeling, if they take that component in the groundwater modeling, and I think that can be useful, or that can be helpful for decision making. I think for the decision makers, because in the cities, as you know, the rules are there, regulations are there, but very few people they are doing rainwater harvesting, because we do not get the permission, construction permission, completion permission certificate, unless we do the rainwater harvesting. So that has to be strictly adopted, and our scientific community can, by using models, they can show the decision makers, yes, by doing this we can solve the problem to this much extent. We can solve the problem of depletion of groundwater, and at the same time we can solve the problem of urban flooding. That's what I think, sir. Thank you.
Good afternoon. We are talking about lack of data required for modeling, and I think we are progressing well for data availability, which may be required in future and in present also for modeling. But National Hydrology Project in third phase exclusively focused on data itself, and we have already created National Water Informatics Center at central level, and 9 states have come up with the State Water Information Center. So very soon we will be having a very integrated structure for data dissemination. As far as surface data is concerned, we are in Central Water Commission. Chief engineers of various basins are custodian of this data, and it is very easily made available to users, especially the academicians, free of cost. And some restriction is there for international rivers for some security reasons, but that is also processed quickly and provided with secrecy undertaking. Uh, we are developing models, we are using data to address the problems which we have created. And the reason is loss of common sense. So we are not hitting the target where we should be. All community problems are created by ourselves for lack of awareness. So my perception is totally different, that rather than going into details of modeling and data, we should focus on public awareness and common sense. You see the one example of Swarna Rekha River in Gwalior. That in state time when Sindhya was there, all Parvati Basin and Sank River is there. So all forested area was there and rainfall was coming to this river. And it was beautifully flowing through the city. Then what happened? Deforestation started in the river bed. People cut off the hillocks and then made it plain to make agriculture. And besides agriculture, they created their house also. So this changed the completely rainfall pattern. So rainfall has gone. Then because of this flattening of the catchment, the flow is gone. So river was dried up. So people started living close to the bank or within the bank. Then there was a flood in 2013, and then government decided to line up this river through the city. So all 13-kilometer stretch was lined up with inverted filters. With time, it was not maintained. Rivers filters were choked. So there is no recharge of groundwater, and river is dried up because no water is there from upstream, and people are starting celebration marriages in riverbed itself. So the case went to High Court. Now court is looking after the problem which common people or engineers should address. So we are knowing that reasons for that, but we are not looking for. We are looking for judges to give directions to solve this problem. So river revival, I have seen in papers that some river was revived in Juna, near Junagadh in Gujarat, one in Rajasthan also, with community involvement of common villagers, not even engineers, doctors, learned people, academicians. Villagers themselves collected the wisdom and resolved it. So we should hit the target. My colleague was talking about rainwater harvesting, but it is mandatory for the construction of a building, but 99% it is non-functional. You see, it is disconnected. When rain starts, it never works. In Delhi, in rotaries, we have water collection here because filters are choked. Two-wheelers are getting stopped because of engine doesn't work because water is there. So problems are common and very easily perceptible, but we are looking for data, we are looking for modeling. What modeling will do? If we develop softwares, we develop, but unless we apply in the field with the common sense, it will not work. So we have to rethink what are the problems of community problems and where we should go. That's all. That's my perception. Thank you.
Yeah, thank you. So it was really wonderful, insights from the experts. I do think about these issues because I am also a civil engineer. Uh, Coming to this urban flooding, I think in this direction. For example, if we are talking about unit hydrograph, no, we are not worrying about whether the duration of rainfall is something or intensity of rainfall is something. So if 1 centimeter excess rainfall is happened, then how much quantity of water is coming? Let us think in that direction for small storms with high intense storms for smaller duration. Then we know what is the quantity of water is expected to come in our particular region, let us say city. One problem I understand is that we don't know what is the drainage network and what are the capacity of those drains. I reached out to some people in Chennai and some other cities also to request for this drainage network plan. They were not able to share, or maybe they don't have, or several issues are there. My point is that, for example, if we know the drainage network, then we can easily see what is the capacity of those drains. Then from this quantity of water, some part of water is being taken care by the drains. So then we need to worry about the excess water which is beyond the capacity of the drain network. Then I thought in the same way, like some of you are said, like Professor Umam Meshwar also, the rainwater harvesting system. We know the what is the how many number of houses are there within the city, at least from the land use land cover map built up area and all. Then if we are assuming that uh, at least every house is having let us say 2000 liter capacity of some tank which is exclusively meant for storing this storm water during the time of storm. After that they will empty it by using or some other manner to handle this quantity. Then if we are calculating how much quantity of water we can accommodate in this tank through this harvesting technique, then separating this volume, then we need to worry about the other part of volume, which is creating inundation or something. Then coming to Professor Somendra said, small cities and all those things. Now, if we see the cities, we have very denser built-up network. More than 60% of the cities were covered with built-up area, majority of metropolitan cities. Then, if we know the soil conditions, then we can easily say that which is the potential recharge zone. Then we can identify the potential recharge zones and we can think whether it is possible to divert the excess water to that potential recharge zones. Then we can recharge through that particular location. To identify this, we have the foundation data, and if we get the foundation data from different parts of the city, at least, then we know that how the soil distribution is there from I mean below the ground level. Then we can just see that what is the maximum depth of foundations at different parts of the city. From there we can easily see that. Then we can check that at what depth the potential recharge zone is there, whether the topsoil is impervious in nature or pervious in nature. Those things we can easily see. Then we can accommodate some part of water through that. After doing this, whatever the excess quantity of water is there, then we need to break our heads for that, like this. So what I am thinking in this way, that so if some x quantity of water is there, then how we can manage in different stage wise, so that then for what quantity of water we need to break our heads. If at least we come up with that, then we can think on what are the again, I mean, available solutions, or what kind of solutions we can think on that. So, but initial stage itself, that means getting the drainage network itself, I felt very difficult for particularly the metropolitan cities. Exactly, I agree with Professor Umameshwar sir, that instead of focusing on the existing metropolitan cities which were haphazardly developed, of course we need to think on that. If we are thinking about the upcoming cities like Indore, Bhopal, Tirunelveli, then Tiruchirappalli, like that, then they were not developed that rigorous. So we can develop some kind of good system at the early stage. Then we can showcase in a maybe due course of time, maybe next 5 years or something. Then this is the model which we want to implement in different parts of the country. At least if we are able to create one such city that is able to uh, 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 manage these urban floods and all these water kind related issues, then by enhancing the groundwater availability, everything, then we can adopt such kind of models elsewhere, wherever the topography and all other things are applicable. In this direction I was thinking, but very difficult. I need your help and all. Thank you so much. And one more thing, just I want to add, sorry if I take more time. I got some data from these cities, from open internet source, that how many people are living in the cities who are not belong to those cities. And I observed that during the time of Sankranti or some Pongal or Dasara or some big festivals, 70% or 60% of city is getting emptied. That means many people are going to their hometowns. Then I see that how many people, I mean, what is the main occupation of those people who are, vacating the city during this period? Most of them are belong to IT sector. So during the time of Corona, many people have done work from home. if we create some kind of infrastructure that uh, creating some small buildings in their hometowns itself, and they can work from those particular small let us say buildings in their hometown. And the industry, if they are creating 20% of employees who can stay in the city, and those 20% can be a dynamic in nature. That means someday you may be living in the city, someday I may be living in the city. Depending upon our expertise, they can call us and they can ask us to stay there. So we no need to do anything, because I adopt this Airbnb technique there. We are carrying our bags itself, and everything got arranged there. Kitchen, bed, everything is getting arranged there. And if I have done my work maybe for 1 month or 2 months, then I pack up and I will go back to my hometown, and I am continuing my work there in that particular location. So there may be creating one building there, set up there. So like this. But this may not work out immediately, but this is one thing I just, I'm thinking in this direction. I may be wrong, but to reduce the capacity of the people, so that we can reduce waste. That is what. No, no. What I want to reduce is demand is one thing. Rather, I think in this way that exposure, community exposure, I want to reduce to this hazard. So this is what. So thereby automatically the loss will come down, something like this. Sorry.
So Dr. Subbarao, these are all good points, no doubt. But there are a couple of things. It's just for the sake of discussion, I'm just telling. All the points are well taken, understood. Demand should be reduced, and the exposure, particularly the public exposure to those calamities, should be reduced. These are all done. But since we are here, we have to debate to come up with some new ideas. That is the thing I'm just focusing on. You mentioned the types of jobs. Maybe we are from some premier institute. There are some IT people where the moving away from the city, maybe the work from home is possible. But we have to remember that many people, they cannot afford that much of quote unquote luxury. They have to come out. If you see the urban population, it is not only about those big festivals, it changes in a diurnal basis also. Any big city you take, daytime population and nighttime population are different. Many people, they do come from the suburbs, so the demand, not only for the season to season, it changes from the daytime to the nighttime also. And at the same time, I do understand the new construction, new cities, new planning, new city planning and all has to be done with all these things in consideration. But we cannot just take our face away from those already existing system. We have to think from those things also. I just want to add a few points so that the discussion can be taken forward, is that there are 3 units. The coordination between three units needs to be improved in a very, very fast rate. One unit is academia. Where are we? We know many problems along with their solutions, but to make it popularize, first of all, the community needs to understand the problem. Until and unless Indore face a massive flood, they will never understand what is the problem. Until and unless the 2015 Chennai floods was there, nobody even thinking of that one, that I need a solution. So that is the general perception has to be integrated. The second group. Third one is the government. Our government needs to, I don't want to use the word understand, but that there are lots of thinking process, quote unquote thinking process is going on in the back of their mind before they take up a solution, quote unquote solution. I can easily say that I can have some underground large reservoir, let the stormwater be stored there for temporarily for 4 or 5 days. After that, utilize it, this one. But the first thing that will come to any government, should I go for the insurance or should I go for this construction? Which one is profitable? If there are 100 cars are flooded, damaged, then I can go for an insurance, and or I can go for the underground construction. Which one will give me the more profit? I remember one thing when I was an MTech student, just started in 2002. One of the actually Professor Sekhar actually he told the arsenic problem and solution was known to them in 1986. General public and the government realizes that one in the early this century. My question is that so these three body, whoever is potential in whatever direction is, they needs to integrate or communicate very very frequently to adopt to understand the solution as well as problem of that solution that government is reluctant to take it up or not. So maybe on this one we can just have some more discussion on this to have some new ideas. Maybe I can just give it to you so that you can throw some light. Where is the government is, what government want from the academia? That's the thing.
Present government is doing well with integration of this industry, government as well as academician. And they are increasing academic courses also accordingly, which can be directly beneficial to this thing. Even we have our one institute, which are technically so good, but it is not of my colleague from NIH. It is not directly connected to public problems. So even our UPSC secretaries are also telling that I don't understand what NIH is doing, because unless you address the immediate problems of the public, your importance is not realized in public eyes. So I think thinking process is gradually changing, that immediately we should address the problem raised or visualized by the people. Like a storm problem also. Again, I will come to common sense. Most of the drains are designed with well perceived data and ideas that it will absorb the storm of the day. The climate change has not changed so much that suddenly we are facing so much rainfall, and after 1 or 2, 3 rains, soil is saturated and it comes to storm. But what happens that whenever your drainage is choked, household sewage system is choked, Nagar Nigam people, they especially break the system and bring their outlet to the storm drains. So most of the storm drains are not carrying only the storm water; they are carrying household sewage as well. So we are talking about over spilling of the banks. It is not because of rains; it is because of household sewage and siltation of the storms. So that aspect has to be kept into account while visualizing or analyzing the data of rainfall or hydrology, because of construction, many quantity of water may obstructed or diverted. So development or haphazard development will reduce the flow to storm. It will not increase. So these factors should be kept in mind, and academicians also should look at these common sense issues of the public, and then, if possible, may incorporate in their studies. That will be beneficial to public. Thank you.
Yeah, just I would like to add a few points. So suppose the stormwater drainage or stormwater management we are discussing now. Now, first thing is that what is the philosophy of design? Okay, so I'm not telling the software is fine, data is fine, so we have data, or we can create some synthetic data or something. Okay, but what is the philosophy? First, we have to understand. Now, suppose there is a virgin area. That means there is no settlement, and I would like to go for a new city or new township there. Then, if I am asked basically that you design the stormwater drainage system for that area. Now, I have to start basically from few points. First thing is that what is the outlet? An outlet invert level has to be designed basically. It's not that I can go to anywhere. So outlet invert level has to be designed. Now, based on the invert level of the outlet, so basically then next step you have to go for the road level design. Okay. And then basically, so now first thing is that it should be in mind. So what is my system is, whether it's a gravity based system or pumping based system. Now, if it is a pumping based system, so you have to give a gradient towards the outlet, and that way basically you have to design the road network, road RL, basically road level or of the. So now I would like to give two example here, that when IIT Guwahati was established, suppose it was started in 1980s, basically 89 or something at that time. What happened? So we did, actually the study was conducted by ISC Bangalore at that time. Professor P.P. Mazumdar was there, and it was a very nice study conducted. So it was a small campus compared to a city, but a very scientific, thorough study was conducted. And then we fixed the invert level first. Invert level, considering the high flood level of the Brahmaputra, basically. The invert level we have fixed, and based on invert level, then basically we have fixed the road level. Okay, so RL of the road level was fixed. And then we have designed the entire drainage system. And so now we do not have any flooding. Now question is that, suppose because we are designing it for, suppose one in 5 years. Suppose if you are designing a very mega city, so you will be designing in 1 in 10 years. Airport, we are designing it for 1 in 100 years or 1 in 50 years. Okay. So these are the return period you are considering for the design of the stormwater management system. Now question is that, suppose if you are designing it for five years, so if you have a rainfall more than 5 years of return period, you will have flood. Okay. But the design philosophy is something that then plinth level comes into picture. That means you have to have designed the plinth level also. So plinth level maybe we can design in once in 10 years basically. So this is, we should fix that once in 10 years, that is the plinth level. That means if there is a flood more than 10 years, 5 years, that water may enter your campus, but it will not enter your home basically. Okay. Now, if it is more than 10 years, certainly it will go to your home also, but we can have some temporary system so that water is not entering. Then even if higher rainfall, suppose 1 in 50 years, 1 in 100 years, there will be some flood or water will enter into your house. Now question is that type of event will be very less. Suppose if we talk about a return period of 25 years, so in my lifespan, hardly I will experience 2 to 3 times. So ideally, if you design in that way, certainly, so we will experience flood, but it will be, frequency will be very less. Now I would like to give another example. So we have now AIMS Guwahati. Okay, so that is basically, we are on the same catchment area that IIT Guwahati has basically. So IIT Guwahati and AIMS Guwahati within the same catchment area. And we are near the Brahmaputra. Okay, so near the Brahmaputra. So drainage line is going through IIT Guwahati campus and AIMS is outside. Now basically when the AIMS, that the ground level was fixed, so they didn't do any study basically. So what they have done, they have taken the highway level. Okay, so whatever the current highway RL top surface, that they have taken as a ground level. They are thinking that highway was designed for something, but it was not designed. And as a result, so our RL, road level is 54 and AIMS road level is 52. So now water is not coming out of the AIMS. So they are under 24 hours of pumping. Okay, so through pumping, so you are putting that one. So I think we did some, suppose if you consider the project of AIMS basically, suppose that it's a huge project. So we are putting a lot of money, and if you go for a hydrologic study, they would have added a few lakhs. Okay. So, but with scientific study, we could have solved that problem. So there are, I think these are some of the issues. So I think whatever your drainage system was designed earlier, it was not designed properly. And basically now we should identify whether we can take out the water under gravity, or if it is not basically, so there may be some pumping station required. But what my opinion is that the problem is not with the software, problem is not with the metrology part. Only thing is that if we design properly, the problem can be solved basically. Okay, so this is just I would like to add. Thank you.
Actually, as our Ministry of Jal Shakti, Sharma sir has rightly expressed that what exactly the ministry want out of the research actually. Our ministry is thrust is on conducting research on the actual real-time issues, real-time problem, which can address the real issues which are being faced by the stakeholders. Your stakeholders can be the state government, your local government, or the government in your jurisdiction, in your area. So, and at the same time, we as academician or researchers, we have also our specialist area also. So we are having the combination as such NIS is concerned. We are having combinations. The scientists, they are working in the area of their own interest, because that is also important, because they have to conduct the basic research, then only they can go for the applied and user defined. But basically, as in the Bhopal and other centers, and even in the headquarter Roorkee, sir, mostly we have the user defined, demand driven projects which are we are conducting nowadays, which are truly based on the to address the issues being raised by the faced by the state governments or this thing. So I think institutes like IIT and NITs also, they are working on the this direction. But having combination of both tools for the research will be beneficial for the institute also, as well as the stakeholders also. That I think.
Discussed.
The design and your experience, whatever you were talking, is a dynamic thing, because when the levels were set at the time, the constructions are not there. And the moment construction, after your drainage things are designed and fabricated, now when the hostel or other things will be constructed, the whole thing will react in a different manner. And the moment you start reacting in a different manner, your design or the fabrications of the drainage system will require a re-look into it. So, and the moment you re-look it, you will find many of the levels will go up, required to go up, and the moment they go up, your buildings will be now suffering the drainage problems. So that's why it's a dynamic problem.